So I'm Chris Romano. I'm a principal system engineer. I previously was at VMware for 16 years. I was employee 87, and I made a conscious decision to come to OVH, right? So there must be something there. It's pretty crazy. Cut 16 years worth of ties to come to a new company. But I also came over with my team, which was really cool. Brought my boss with me and everything else. So it was a crazy kind of week when we heard about the announcement. But once I thought through it and kind of looked at things with clearer eyes, I decided to come try this out. And it's pretty exciting because we're effectively a startup here in the USA. All right. Oops, I got a clicker. So there are some forward-looking things we're going to be talking about today. We're not going to commit to anything here today. We'll give you some general ideas of what's coming, how we think it'll look. We're basically taking what's been done in France and the rest of the world, where the OVH Group's headquarters is, and bringing it to the USA. We do know some of the things that we're going to start with, but they offer a lot of stuff over there. They do web hosting, they do voice over IP, and things that we probably won't have here in the US. But any of the enterprise solutions that they have, we'll be bringing here. So pricing and packaging and all that kind of stuff has not really been determined yet. We're actually going to release pricing in 4 to 6 weeks. So we'll talk about who OVH is a little bit. Very, very quick product review, one slide, just to kind of give you an idea of what they offer. Then we'll talk about the security components here. So the stuff they do at the perimeter is amazing. Nobody in the US does anything like this. And we'll give you a good perspective on that. And then we'll talk about defense within the virtual data center. So we're going to talk about a lot of things that we were already doing in vCloud Air. So this really is a marriage of two technologies. It's a marriage of what we did with vCloud Air, which was targeted at the enterprise, which did really amazing things to like reconstruct the enterprise inside our virtual data centers, inside our cloud. Kind of married with a real data center provider that builds everything from the ground up, owns it all. And we're kind of merging those two things together to create a real solid enterprise solution for our customers. These guys, OVH didn't have a lot of enterprise experience, so they literally bought the ability to sell to and work with the enterprise by picking up all the personnel they brought with. Then we'll talk about how we extend the data center, and if there's any Q&A, we can have that. If you have any questions along the way, please jump up on the mic or raise your hand or whatever, and we can talk. All right, so who is OVH? Fifth loudest cloud provider in the world. They have data centers all over the world. Currently, we have 27 data centers in 11 countries. 2 are being built here in the USA. So we have a data center in Hillsboro, Oregon coming online, and one in Vint Hill, Virginia, just south of Washington, D.C. And they'll be available in October, November timeframe. Okay? These guys came over here. They brought all their French guys over to build these data centers, and they're building the data centers as we speak. The network... the net ops room and all the cages and the servers are already being deployed and everything, and they should be online in a couple months. The goal, though, is to have 6 data centers in the US by 2020 and a total of 50 data centers globally. And they are the 5th largest cloud provider in the world, and we always jokingly say the largest cloud provider in the world that nobody knows. Nobody knows the name here in the US, right? So we're hoping to change that a lot over the next year or two. 1.3 million servers capacity. They've already got about 250,000 deployed, right? They have 1 million customers in their data center. They host all kinds of stuff. They do a lot of web hosting. And again, they do a lot of other services and things like that. What we're really interested in is what we're going to do around the cloud, providing, again, enterprise class cloud. The interesting thing, though, is these guys are 19 years old. So OVH built their first data center in the late 90s, I think is a web hosting type data center. And they quickly moved into hosting and then cloud. So as virtualization became common, as a lot of vendors, they said, let's get into cloud. Let's take advantage of virtualization and create that elastic capacity and all that. So they did it and became one of VMware's largest vCAN partner. So they were an obvious fit when VMware was looking to sell vCloud Air, they were an obvious fit. So they predate Amazon in data center. Amazon's first data center came online in 2005 or something like that. So that's pretty cool when you think about it. These guys really know what they're doing. So here's the data center construction. They do it in a couple of different ways. They can take a shell of a building and turn it into a data center in 6 months. They use this modular concept, this picture up on the top screen. They call it a pod. Kind of, in the old days we had those container, remember data centers in a container? That got to be really hot for a while. These guys actually architect the pod, cutting their own sheet metal, bedding their own rails, all that kind of stuff. So here's some examples of their data centers. And then they can build data centers from scratch. So this one is Roubaix number 4. This blue guy here on the far right. It's like a 6-story data center. Really, really cool. This is where it gets to be really cool for us. This is like the first thing I heard that I went, wow, it's kind of interesting. So you see these little red and blue cables? These are actually tubes that pump cool water in to a die that's attached to the CPU. And they cool the chip with cool water, pump out the hot water through the red tube. They mist it through like nuclear plant type cooling systems. They mist it against sheet metal, cool it down, and then recycle it back through. It's actually not water, it's a liquid coolant. And they dissipate 70% of the heat that way alone, right? Then they use natural airflow, so vents and fans just to push air through the data center. So the thing different about their data centers, when you walk in, you think, uh-oh, the AC unit's down because it's like a balmy 70 degrees in one of their data centers, which is actually perfect because all the cooling's happening down at the chip level. So it doesn't really matter what the ambient air is. It's being handled down there at the actual CPU level. Really, really cool stuff, cutting edge, right? So that's how our data centers will operate here. So if you want to run around with the banner of I'm a green data center, these guys can really make that claim. So here's the core offerings. So hosted private cloud on the left-hand side is what we were doing in vCloud Air. It's also what they were doing previous to us. So the model for vCloud Air was to build customer tenants and customer environments and subscriptions on vSphere, right? And what the intellectual property we took to build that, we gave that to our vCAN partners. So our vCAN partners effectively subscribed to our methodology, and they created very similar data centers. So they look, acted, and felt just like vCloud Air. They had their own interfaces, that kind of stuff. The other thing we're going to offer, though, and the next logical progression here is SDDC. So I'm just going to call it out. So vCloud, VMware Cloud on AWS. This is really effectively the same exact model. Using OVH hardware. That's going to be what they call hosted private cloud. They're going to host your private cloud, as well as some of the other scenarios we do, which is data center extension, which is extending your on-premise cloud into their hosted private cloud. We're also going to provide disaster recovery. We may or may not offer a on-demand type thing, the t-shirt size VMs. We'll talk about OpenStack more in that realm a little bit. But predominantly it's going to be a subscription-based capacity purchase. You'll buy your 4-server cluster. It's deployed in 2 minutes. So one of the things they've done is automate the hardware. These guys can actually deploy a cluster of servers in 2 minutes time. You go online, you order them, place your call, submit your PO, and your 4-node cluster is up and running, ready to go. In the middle is what they call public cloud, and that's a pure OpenStack play. It's not their version of OpenStack or some weird iteration. They're just using publicly available OpenStack tools, Neutron and whatnot. And that is kind of the developer play. So the model is if you need a lot of VMs really quick and you want to spin them up, microservices, containers, you go with the OpenStack route. Again, all full automation, open APIs available. You can program yourself, do whatever you want to do to enhance your automation, change the model. This would also be a good example for a burst to cloud type concept, where you can actually just spin up a cluster, run a short process for a while and destroy it and it goes away. And that's the two sort of virtual offerings. The other neat thing though is they offer dedicated physical servers. And I'm going to talk a little bit more about servers in a second as well. So we used to do a lot of colo, or not a lot, but we had customers that would be like, hey, I want to build my cloud, I want to put my DR, I want to build my infrastructure as a service, but I got this giant file server, I have a switch, or I have an AIX box or something like that. So with the dedicated servers, we can offload 80, 90% of those use cases. So if somebody were to come to us and say, I want to host my Exchange environment in your cloud, we'd provide them dedicated servers versus actually hosting their servers, right? So it gives us a lot of options. Things like AIX obviously are a little bit different. But so that's the 3 core offerings that we're going to start with. And if you go look at their website, they have some really cool stuff. Let me talk about their servers. They actually build their own servers. They literally cut the sheet metal. They have laser cutters in their manufacturing plant, cut the metal, put all the components in it, system board, chipsets, put it in, plug it into a chassis, it's ready to go. The neat thing about that is that when it hits end of life, 3 to 5 years, these guys do something really slick. They take the guts out, system board and the rest of it, reformat into a blade offering, which they stick into a chassis and they sell it for €5 a month. And that's called Consufi. So if you're looking for a real low-cost server, Consufi's the way to go. And the story I like to tell is one of the old VMware guys came to me and was telling me about blockchain and all this stuff, and still don't understand it. But anyway, him and his kid were gonna go buy 5 servers and build their own blockchain. He's invested in Bitcoin somehow. He owns like 2/3 of a Bitcoin or something. And him and his son are gonna build it out, do some bonding, I guess. And I told him about Consufi, and he goes, €5 a month? He goes, I was gonna go buy 5 servers. He goes, man, you're telling me I can have, for €25 a month, I can stand up 5 servers? And I'm like, yeah. So that's an offering available in France today that maybe we'll see a version of it here, but you can go online and buy a Consufi server for nothing. So they take those servers and extend the life, theoretically indefinitely. I'm sure at some point they pull the blades out and destroy them or whatever. But so down here at the bottom, they own their own fiber network. So they lease the physical fiber, but they're not sitting on top of somebody else's underlay. It's actually their network. So everything can be architected up to 11 terabytes of throughput. I think it's typically lit like 3 to 4 terabytes all the time, but they can handle actually up to 11 terabytes of bandwidth on their own network, right? We'll talk about anti-DDoS later. We'll talk about the private LAN VRAC. We're going to provide high-touch customer service and support. So that's one of the things we bring over from VMware, is when you did a subscription to vCloud Air, you were given a cloud architect and a customer success person to kind of act as your TAM, your remote TAM sort of thing. And again, global hyperscale reach. These are their POPs, their points of presence. They have 32 of them globally. So we can interconnect you anywhere. If you want to run some VMware Cloud on AWS and you want to run something specifically that OVH is the best fit for, we can connect those guys through one of these POPs, no problem. All right, so why are we here? We're here to tell you the story of what these guys do with security, how they are differentiated in the security layer. We did some pretty cool stuff in VMware and vCloud Air as well, but adding what OVH brings to the table really makes this a real robust security solution for you. So if security is paramount and you want to put it into a cloud, I'd say that OVH is probably the best choice. So let's talk about the perimeter. So you guys remember that Dyn attack in October of 2016? Brought down Netflix, AWS went down, everybody was impacted. Dyn went down and it ripple effect throughout the industry, right? Really, really cool stuff. Headlines all over the place. World's coming to an end. Europe gets hit with a 400 gigabit attack. Cool thing was, 1 month earlier in Roubaix, France, they had the same attack. You didn't read about it in the headlines, right? Well, first of all, it was in Europe only. They didn't have an American presence. They had a 1 terabyte attack. And what you see on the right here is our founder, Octave Klaba. He's our CEO, founder of the company. He's tweeting as the attack's coming in. And at this point in time, he's looking at almost a terabyte of data coming in, right? So how did they handle that? How did it not impact them? And it brought Dyn down. And I'm going to explain to you why that's happening. And they see SYN flood attacks to the tune of up to 1,500 a day sometimes. It's really prevalent. This is getting to be a massive problem. Guys sitting in their mom's basement and going, let's mess with everybody, right? That's what they're doing. Let me see if I can bring this down. Let me see if I can bring that down. But these guys are poised to take it on. They're saying now that in 2016, they saw 19 attacks over 100 gigabyte. Now we're pushing them to a terabyte. So who's better poised to handle an attack larger than a terabyte than somebody with an 11 terabyte backbone? And when I say 11 terabyte backbone, it's throughout the entire, their data center architecture. So all their data centers are interconnected at that sort of bandwidth. So they're increasing by 125% annually. Just got that video off of YouTube. It's kind of cool, right? And somewhere out on Norse, there's probably the attack that hit OVH is probably sitting out on Norse somewhere. I should probably ping them and see if we can get a version of it. So here's the attacks. There's 16 different attacks they monitor for and use their DDoS mitigation to work against. Again, most of them are SYN flood attacks, but there's all kinds of other things here. TCP, SYN floods, and all these other guys. So here's how they do it. Now we don't give you all the gross details of how they do it. Obviously, they don't want to give it away, the secrets. But at a very high level, what happens is at the first bullet point there, everything's operating normal. Inbound, outbound traffic, everything's going through. They're using NetFlow to monitor, right? So every 2,000 packets they look at, and as soon as they see some sort of oddity, some sort of nefarious activity, something coming in that's not normal, that fits into the signature of one of those 16 types of attacks, they activate the mitigation. So within 15 seconds to 2 minutes, they're already redirecting the traffic with dynamic routing, pushing it down to what they call their VAC system, all right? So this single point here, this VAC, is actually represented by 4 different tools that go ahead and fight the attack and clean up the attack and filter the attack, right? So that happens within 15 to 120 seconds. At the end of the attack, they maintain auto mitigation for 26 hours to make sure there's no follow-on. People like to do that. Wait and then send another attack, right? So this is what it looks like. The 4 components are a pre-firewall, so that's OVHs, that's at the edge of the data center. They manage that. There's also a customer firewall that you can configure, so you have some ability to do very specific IP filtering and stuff on your own. And this is actually different than the firewall down in your subscription tenant, all right? So this is all at the edge of the data center, effectively. And then Shield, which does UDP reflection and amplification, attack filtering. But the heavy lifting is actually done by Armor, right? And this does most of the work. SYN authentication, zombie attacks, payload patterns. It does all the cleanup. It allows the clean traffic through. All the proper acceptable traffic that's supposed to go through goes through, while the other traffic is being routed to the VAC and being cleaned up and filtered and stopped and halted and blocked, et cetera, et cetera. So again, kind of reiterating what I said before, they're using NetFlow basically to monitor their traffic. They compare it to their attack signatures, kick on the mitigation, and clean it all up and stop it. This is how they're able to stop a 1 terabyte attack, and Dyn couldn't, right? Any questions so far? Good to go. So that's something we couldn't offer, vCloud Air, you know what I mean? We were doing everything we could at the edge of the perimeter like anybody would in their data center to protect it. But these guys are offering something that just, they've architected. This is all proprietary stuff, unique to them. 60 years of VMware, excuse me, I gotta get used to saying unique to us. I keep going unique to them, and I'm one of them right now. So the other neat thing is they can actually activate this on a global level. So let's say we had a greater than 1 terabyte attack. So this represents the Roubaix data center, RBX. They can actually kick in mitigation and kick on the VAC system in another data center and redirect traffic there with dynamic routing. So they can have another terabyte attack thwarted from another data center's VAC system. They can actually leverage the entire global reach of their VAC system to thwart those attacks. Really, really cool stuff. And there's a article on the web called the DDoS that didn't break the camel's VAC. And VAC effectively means vacuum. It's vacuuming up bad stuff, right? Dirt, garbage. So out here at the edge of the data center, there's also some additional protection. Remotely triggered black hole using dynamic routing. The VAC system, obviously. Anti-hack, anti-phishing, anti-spam. A lot of the stuff you would already expect. Redundancy of all components, right? So their blades, like I told you, they can provision a 3-node cluster, 4-node cluster in 2 minutes time. The neat thing about this is everything's redundant, so they have spare capacity. If your 4-node cluster loses a node, you got VMware HA taking care of all the failover, they can have another blade up and running in minutes time, ready to go, added right back to your cluster. That's all automated. These guys are masters of automation. So again, automation at the hardware level, kind of unheard of. Fire risk management, high security data centers, human presence. Their data centers are really interesting. When you go into one of their data centers, you have to go into an airlock. You have to be weighed when you go in the data center, and they weigh you when you come out, like if you stole a hard drive or something. Just don't have a snack while you're in the data center. Might be a problem. So they actually have really, really high security. It's not like Switch where the guys are walking around with MP4s to be impressive, but they've got armed guards all over the place as well. So defense within the data center, right? So all the way up to your tenant, to your edge gateway, you've got all that protection kind of happening automatically for you with some customization. So remember, you got that one firewall you can kind of tweak and do some stuff too. So at the edge of your subscription, the edge of your tenant, NSX sits. In the traditional vCloud Air model, it was an NSX edge gateway that sat at the edge of your tenant. With the SDDC stack, it's NSX as you know it on premise, just built in our cloud, right? So you have access to NSX Manager just like you would on premise, right? You can build those gateways all day long. You can do whatever you want. You can segment your tenants however you want to do it. And it's providing, 5-tuple firewall rules, NAT translation, DHCP. All these services are available at the edge gateway. SSL, 200 sub-interfaces, plus distributed firewall, all right? So one of the things we're considering, today the current vCloud Air architecture is built on vCloud Director. Okay, it backends, and the interfaces are custom interfaces designed for vCloud Air, no vCenter access. So for our legacy customers, we do have customers that use vCloud Director on premise, so we'll probably bring that model over to accommodate, and any of those customers that want to stay in that legacy model will be able to. Anybody who wants to move to the software-defined data center, the SDDC, the VMware Cloud on OVH, if you will, to borrow heavily from AWS, that will be available to them as well, with all this capability and then some. So you guys get microsegmentation, distributed firewall. You understand the kind of the tenets of NSX, I'll assume. It's in kernel, it's line rate speed, it adds zero trust security model, handles all the east-west hacking, all that kind of stuff. The cool thing about it running in our cloud is we've got two different ways of protecting. We've got north-south protection with the standard stateful firewall, right? 5-tuple firewall. This port's blocked, this port's not, et cetera, et cetera. And then we have the east-west protection with microsegmentation. This app cannot talk to that app. Anything with web in its name is never allowed to talk to FTP, et cetera, et cetera. All those custom configurations that you guys can create. If you're not running NSX on premise, I would venture to say that your application would be more secure in our cloud because of this than they would be on premise. If you're running it on premise, you already get the gist of it, and you're like, cool, I need that in the cloud too. So we have customers that want to learn NSX. They're vetting it to deploy it on premise, which can be a large proposition when you have to kind of move to a software-defined data center model. And they get a subscription to kind of learn how it works inside our cloud. And then spoof guard. So we can detect and stop and manage IP address spoofing. So we can have a manual process where somebody has to approve that IP before it ever gets through. And this is actually at the VNIC level. So that we can do things like thwart somebody who wants to get around distributed firewall rules by spoofing a different IP address. So if you're using static IP addressing versus dynamic rules in the distributed firewall, you can stop somebody from spoofing an IP address to get around those rules, which is pretty cool stuff. Again, this is from the interface. This is what it looks like. You're sitting at the NSX Manager inside our cloud. And then third-party integration. So today we don't offer encryption at rest, but you can do guest-level encryption with companies like HighTrust. There's a couple other ones out there that will do this thing. And when our SDDC stack is moved to 6.5, you'll be able to take advantage of vSphere encryption when that's available as well, right? So these kind of things are available to you, as well as all these other partners. These are all partners of ours. Let's say you don't want to use the NSX Edge Gateway. You want Juniper, drop a Juniper virtual appliance, one-to-one NAT it from our gateway to that appliance, and it's all yours to manage using the stuff you know and love, which you're comfortable with. I showed a customer one time that they could replace their F5 firewalls with our Edge Gateway, because we do load balancing, and VPN and a lot of the other stuff F5 offers, and it was going to save them about 120 in years at virtual appliance costs. They had about 25 different F5 appliances they were going to put in the cloud. We did a look at their iRules and compared it, and there was like just a couple features we couldn't do. So they stuck with it. But you can leverage our resources if you want to get away from some additional cost and some of these things. But we don't do everything that all these partners do. These partners bring value that we'll never have or we don't currently have today. So again, if it's a comfort thing, go for it. If it's a feature you really need and somebody provides it, as long as it can be virtualized, it can be run in our cloud. Matter of fact, these guys at ESET are one of our customers. I just had lunch with one of those guys. Did he show up? Ah, darn. So yeah, another partner of ours as well as a customer. So securing the extended data center, right? So this is the value proposition of any vSphere-based cloud. This is what makes it appealing to people. This is why VMware invested, a software company invested in their own cloud. They're like, let's provide something so that if people want to move their workloads around, they're moving it into a cloud like ours. It was always designed to be the template for vCAN partners as well as customers that trust and believe in VMware and want to use, just take their virtualization, extend it to the cloud, into a cloud. That's like for like. So the cool thing about it is, again, we always go into this conversation, we walk in and we're talking to somebody who wants to look at Azure or AWS, and the problem right now, of course, VMware Cloud and AWS aside, is that the formats are different. So the VM has to be exported with some sort of tool, reconfigured, there's got to be some kind of scripting, there's things that have to be done to make it work in that cloud. A VMware VM, as long as I can get it in the cloud, it hits the ground running, right? At one point, our cloud was sitting in 5.5 and people were sitting at 6.0, and the only challenge we had was the hardware version. Had to stay that couldn't be beyond 11 for a short period of time. But in general, it's sort of backwards compatible. So Hybrid Cloud Manager is the tool that VMware created to migrate the VMs in and out of our cloud. And it does three key things, right? It does migration and replication of the VM. It creates a layer 2 tunnel. And it does WAN optimization, all right? So that the virtual machine can move across a segment and land on that same segment in our cloud. We've done a stretch layer 2 for you, right? In software, we're leveraging the capabilities of NSX. All you have to do is drop a fleet of appliances on premise, connect it to the subscription in the cloud, bit of configuration, you're up and running, and now you can vMotion a VM into the cloud. First of its kind. Nobody, there's ways to do it. Once the latency was increased to 150 milliseconds for vMotion, with the right kind of networking configuration, customers could do it. But this is a tool that enabled it, specifically for cloud use. Once the latest version, which is called HCX, which has some added capability around disaster recovery and whatnot, is released, we'll be doing that as well. I think we have an exclusivity to this for a little bit of time through the sale of vCloud Air. It uses Suite B encryption. Everything's encrypted from end to end, everything in flight, so it's a total secure way of moving your VMs into the cloud. It also allows you to bring your security policies over as well. So if you are an on-premise NSX cloud customer and you configure microsegmentation rules on a VM, and it will take its security profile with it into the cloud. It'll bring its security with it. And this is always something that we, back in the old days of VMware, we always talked about this, how cool it would be for a guy to be able to bring a security posture with him. And that's what one of the other advantages you get from Hybrid Cloud Manager. All right, so we're talking about extending your data center into the cloud, creating a layer 2 network that stretches all the way out to a data center somewhere else, right? All in software. Here's where it gets really cool, and this is where Paul gets really excited, man. This VRAC thing is pretty amazing, all right? This is VRAC. When I first heard it, I went, VXRAC? No, it's not VXRAC, it's VRAC. Again, remember, these guys were found in the late 90s, so these terms they came up with in a bubble. They didn't steal, they had this name before EMC had VXRAC. And what it is basically a virtual rack. So a server sitting in this data center is connected to a server in this data center over the same VLAN. Right? Layer 2 adjacency globally. So all these VMs are talking to each other over the same segment globally. And the cool thing about it is it's customer configurable, right? So you go into the interface, and let's say you had 2 subscriptions in your Montreal data center. You literally choose your subscription, let's just say the subscription ID is 2015. You click on it, you choose which VRAC you want to drop it into, so you drop it into the VRAC that's configured for VLAN 10. You go into your France data center in Roubaix, France, grab your subscription that's 2014, drop it onto the same VRAC, now they're sitting on the same VLAN in 2 different data centers on 2 continents. And that works across all your subscriptions. Dedicated servers, SDDC stack, the OpenStack offering, all of that is configurable and can all be configured to be on the same LAN. Nobody in the world can do this. Now this is a hardware solution, right? We can do stretch layer 2 with our software solution. This is kind of taking it to the next level. And then the other cool thing it does, it can do what HCM does. It can stretch it into your on-premise data center. And this is called VRAC Connect. It's another offering we have that allows you to configure a link aggregation, a connection from on-premise into the cloud. You have to do some configuring on your switch as well to set it up for you as well. So that's VRAC, and this is free. DDoS protection, you buy a subscription, dedicated server, or a cloud offering. This stuff just comes with it. There's no additional charge for this stuff. That tells you why they have 1 million customers. So just as a side note, because of these efficiencies these guys do, just around the efficiencies of not needing air conditioning units and natural air cooling and all the cost savings they have there, they're actually able to sell things at a cheaper cost. The CEO was on a video today, and he was saying that he's hoping that 50% of what might be charged for a certain resource might be a goal we're going to be trying to target. So we're looking for some pretty good cost cuts, and that's going to be one of our competitive differentiators, is how cheap the stuff's going to be at, plus the value add of other things added to it. So again, we're a global hyperscale company with a 19, 20-year history. Customers have more options, more data centers. We had 5 for vCloud Air, and they were basically all lease space. We didn't have our own data centers. These guys have data centers all over the world. So if you're a international company, you have the ability to put your stuff close to wherever your assets are globally. The industry-leading DDoS protection, as well as all the back-end security, adds layered, in-depth security for you at a level that most cloud providers can't provide for you. So that's it. That's all I had. I know I was going to burn through that pretty quick. This is where our booth is. If you want to see demos on some of this stuff like VRAC and whatnot, it's available in the booth. You can tweet us, Twitter us, Facebook us, all that kind of stuff. And then here's the rest of the sessions. I think we have a couple more. This might be the last one. No, we got another, the 2 o'clock session's over. So that's a wrap, isn't it? Yeah. So are there any questions? No? Awesome then, man. I'm going to give you 25 minutes of your life back. There you go. Thank you very much.